Hello and welcome to Algebra 2 Lesson 28. In this video, we're going to learn about solving systems of linear equations in three variables. So up to this point, we've become very familiar with how to solve a system of linear equations in two variables using graphing, using substitution, and using elimination. Now, we're going to rely on all this knowledge to get us through the next challenge, which is solving a system of linear equations in three variables. Before we learn how to solve that type of system, we first need to familiarize ourselves with a linear equation in three variables. So a linear equation in three variables looks like this. It's ax plus by plus cz equals k. So just something times x plus something times y plus something times z equals some constant. So we would say a, b, c, and k are just real numbers, where a, b, and c are not all zero at the same time. Because again, if you had that, your variables would all drop out. All right, so let's look at an example of this real quick. I think if we just use our prior knowledge of working with a linear equation in two variables and extend it to a linear equation in three variables, we're pretty much good to go. We've just added a variable here. So we have 4x plus 2y minus 3z equals negative 14. And I have a sample solution, okay? We know when we work with a linear equation in two variables, we give our solution as an ordered pair. Now we're going to have a solution as an ordered triple. So instead of just an xy, it's an x, a y, and a z. And it's in that order. So as this example goes, I have this ordered triple. This 1 is an x, this 0 is a y, and this 6 is a z. So I should be able to plug in a 1 for x, a 0 for y, and a 6 for z, and I should get a true statement. So I would have 4 times 1, plug in a 1 for x, plus 2 times 0, plug in a 0 for y, minus 3 times 6, plug in a 6 for z, and this should equal negative 14. So 4 times 1 is 4, 2 times 0 is 0, negative 3 times 6 is negative 18, this should equal negative 14, and it does. You'd basically have 4 minus 18, which is negative 14, so that does equal negative 14. So this works as a solution. But just like we saw with a linear equation in two variables, a linear equation in three variables is also going to have an infinite number of solutions. So I could just generate as many ordered triples as I want as solutions for this equation. All right, so now that we know what a linear equation in three variables is, what if we get a linear system in three variables? So this is going to contain three equations with three unknowns. So solving a linear system in three variables. The first thing we want to do is we want to write each as ax plus by plus cz equals k. Why do we do this? Well, we're doing it because in the next step, we're going to do some elimination. With elimination, we remember our first step is to write ax plus by equals c when we have two variables involved. Well, it extends to this with three variables. I just have plus cz. The reason we do this is because we make it easy to see what we're going to be able to eliminate or what we would need to eliminate a variable. All right, so now that we've done that, we use elimination to eliminate one of the variables from any two equations. Doesn't matter what variable you pick, doesn't matter what two equations you pick. But in the next step, it does matter. You need to eliminate the same variable from any other two equations. So if in that last step I eliminated x, when I get to this step, I've got to eliminate x again. What that's going to do is it's going to give me a linear system in two variables. If I eliminated x, I'm going to have y and z. Once I have a linear system in two variables, we already know how to solve that. So solve the linear system in two variables. You can use substitution or elimination, whatever you want to do. Use the result to find the third unknown. Once I know what two of them are, I can go back to any original equation and find the third unknown. The last step, and always the most important, check the result in each equation. So you're going to plug in for each x, y, and z in each original equation. Now, the one thing that always comes up, and a lot of students ask this, they say, can you use substitution the whole way through? So in other words, can I use substitution to generate a linear system in two variables and then solve that with substitution and end up with the answer for my linear system in 3 variables? The answer to that is yes, you can do that. The reason that we generally don't teach that is because it's super tedious. If I solve one of these for one of the variables, and then I plug that in to the next 2 equations, I will generate a linear system in only 2 variables, but to do it will be super tedious, and it's very prone to errors because of that. So let's start out with what we have. We have negative 6x plus 4y plus z equals 20. I'm going to call this equation 1. Then I have negative 2x minus 6y minus 5z equals negative 22. I'm going to call this equation 2. And I have 2x minus 2y plus 4z equals 10. I'm going to call this equation 3. Now, everything is already written for us as we were told to do, as ax plus by plus cz equals k. So we don't need to do anything on that front. We move immediately into picking one variable to eliminate between 2 equations. So if you look at everything, it looks like it's pretty easy to eliminate x between equation 2 and 3. I've got negative 2x and I've got 2x. So that would work out pretty nicely for us. So if I've got negative 2x minus 6y minus 5z equals negative 22, and if I've got 2x minus 2y plus 4z equals 10, I can sum the left sides together and set this equal to the sum of the right sides. So negative 2x plus 2x is 0. X has been eliminated. Negative 6y minus 2y is negative 8y. Negative 5z plus 4z is negative z. And negative 22 plus 10 is negative 12. So I've produced an equation that is x-free. So let's call this equation 4. This is negative 8y minus z equals negative 12. All right, now, the next thing I want to do is I want to get any other 2 equations. So I worked with 2 and 3, so it either needs to be 1 and 3 or 1 and 2. So one of those scenarios, I need to eliminate x from those. So let's go ahead and just do 1 and 3. Because I have a negative 6 and a positive 2. So the coefficients are opposite signs. They're not opposites yet, but they're opposite signs. So that's a little bit easier. So we have negative 6x plus 4y plus z equals 20. And then for equation 3, I have 2x minus 2y plus 4z equals 10. Now, if I want to make these opposites, I can multiply 2x by 3. But to make that legal, I've got to multiply both sides of the equation by 3. So 3 times 2x is 6x. 3 times negative 2y is negative 6y. 3 times 4z is plus 12z. 3 times 10 is 30. All right, so let's erase this, and we'll just drag this up here. And again, I'm going to add the 2 left sides. Set this equal to the sum of the right sides. Negative 6x plus 6x is 0. So again, x has been eliminated. 4y minus 6y is negative 2y. Z plus 12z is plus 13z. 20 plus 30 is 50. So what this would produce, and let me kind of move this down to be in line. For equation 5, we'll call it, this would be negative 2y plus 13z equals 50. Now, let me erase this. I have produced a linear system in 2 variables. So now, we know how to solve this. We've been doing this forever now. The only other side note I would say is, we did that so much quicker than if I, let's say, solved for z, and then I plugged in for z in this equation and this equation. Again, that's the substitution method you could use. That would produce a linear system in 2 variables with just x and y, and then I could solve that as well. But again, using that method is just ultra tedious, and I want to try to stop you from doing that. You could pause the video, try it that way, and just see how long it takes you to produce a system like that. It's going to take you a long time. All right, so now I have my linear system in 2 variables. It looks like this one is easier to solve with substitution. I have a coefficient of negative 1 there. So let's go ahead and solve this for z. We have negative 8y minus z equals negative 12. Let's go ahead and add 8y to both sides of the equation. That would cancel. I'll have negative z is equal to 8y minus 12. Let's divide both sides by negative 1. And so this is going to produce z is equal to negative 8y plus 12. So I'm going to drag this over here. Z is equal to negative 8y plus 12. All right, so we all know how substitution works. We're going to substitute in for z in this other equation. So I'm going to plug in here, and I'm going to be plugging this in. Z equals, or z is the same as, negative 8y plus 12. So I'll have my equation 5, negative 2y plus 13 times, in place of z, I'm going to plug in negative 8y plus 12, because z is the same as that, and this equals 50. So I'll have negative 2y plus 13 times negative 8 is negative 104. So I can go ahead and put minus 104y. And then 13 times 12 is 156. And this equals 50. So negative 2y minus 104y is negative 106y. Then plus 156. And this equals 50. So if I subtract 156 away from each side of the equation, this will cancel. I'll have negative 106y is equal to 50 minus 156 is negative 106. Scroll down and get a little room going. As a final step, let's divide both sides by negative 106. This will cancel. I'll get y is equal to negative 106 over negative 106 is 1. So y equals 1. So we found one of our unknowns. So let me erase everything. So now I'm going to keep working with this linear system in two variables. I'm just going to list that y equals 1 for now. So I can plug a 1 back in for y here or here, doesn't matter. It's easier to work with equation 4. So let's go ahead and do that. So in equation 4, I'd have negative 8 times, plug in a 1 for y, minus z equals negative 12. Negative 8 times 1 is going to be negative 8. Minus z equals negative 12. Let's add 8 to each side of the equation. That cancels. You'll have negative z is equal to negative 12 plus 8 is negative 4. Multiply both sides by negative 1. You'll get z is equal to 4. So y equals 1, z equals 4. All right, so now we know two of our unknowns. And now we can turn to our original system of equations. So I go back to equation 1, 2, and 3. So y equals 1 in every equation. Z equals 4 in every equation. So I can plug into equation 1, 2, or 3, doesn't matter, and find the value of x. So let's just go ahead and work with equation 3. So if I have 2x minus 2y is 1, so 2 times 1, plus 4 times z, z is 4, this should equal 10. So I'd have 2x minus 2 plus 16 equals 10. So I'd have 2x, negative 2 plus 16 is 14, and this equals 10. Let's subtract 14 away from each side of the equation. This will cancel. I'll have 2x is equal to 10 minus 14 is negative 4. Let's divide each side of the equation by 2, and we'll have x is equal to negative 2. All right, so I found my value for x. X is negative 2. And let's go ahead and write this as an ordered triple. Remember, it's the x value, so that's negative 2. The y value, so that's 1. And the z value is 4. So the very last thing we want to do is check. And I know checking takes a long time and it's tedious, but it's very important that you check if you have the time. If you're on a timed examination, what I always do is, or what I always suggest that you do, would be to go through everything first, make sure you can complete your test, then go back and check your answers. Start with the ones that you think you got wrong. And then if you have time, check everything. All right, so let's start with equation 1. So I would have negative 6 times, for x I'm plugging in a negative 2, plus 4 times, for y I'm plugging in a 1, plus z, which I'm plugging in a 4. So this should equal 20. Negative 6 times negative 2 is 12, plus 4 times 1 is 4, plus 4 equals 20. 12 plus 4 is 16. 16 plus 4 is 20. So you get 20 equals 20. So it does work out here. For equation 2, okay, for equation 2, we have negative 2x, so x is negative 2, minus 6y, y is going to be 1, minus 5z, z is again going to be 4. This should equal negative 22. Negative 2 times negative 2 is 4, minus 6 times 1 is 6, minus 5 times 4 is 20. This should equal negative 22. 4 minus 6 is negative 2. Negative 2 minus 20 is negative 22. You get negative 22 equals negative 22. So it works out here as well. And let's check equation 3. So we'd have 2 times x, x is negative 2, minus 2 times y, y is 1, plus 4 times z, again, z is 4. So this equals 10. 2 times negative 2 is negative 4, minus 2 times 1 is 2, plus 4 times 4 is 16. This should equal 10. Negative 4 minus 2 is negative 6. Negative 6 plus 16 is 10. So you get 10 equals 10. So it works out here as well. So we found our solution for our system. It took a while, but we did find it. It's the ordered triple, negative 2, comma 1, comma 4, which is an x value of negative 2, a y value of 1, a z value of 4. Now, I'm not going to check everything moving forward just for the interest of time because it takes forever. But I want you guys to pause the video just so you know how to check things. Plug in for every x, plug in for every y, plug in for every z, and make sure all of the equations are true with our solution. All right, let's go ahead and take a look at the next example. We're going to kind of speed things up just a little bit. So I have negative 3x plus 18y equals 19 plus 12z. I have negative 9x minus 6z equals negative 19 plus 18y. I have negative 6y minus 12z equals 2 plus 18x. Now, this is not in the format that we'd like it in. We want it in ax plus by plus cz equals k. Do we have to have it in this format? No, but it makes it convenient for us to see what's going to cancel, what we need to do to cancel. We don't want to be looking all over the place to find z and x and all these things. We want things lined up nice and neat. So for the first equation, I'm going to write negative 3x plus 18y. If I subtract 12z away from each side, I can put minus 12z over here, and this would be equal to 19. So this would be my equation 1. For equation 2, I have negative 9x. I could subtract 18y away from each side, then minus 6z, and this equals negative 19. Okay, this is my equation 2. For equation 3, let's subtract 18x away from each side of the equation, then minus 6y, then minus 12z, and this equals 2. So this would be my equation 3. All right, so let's scroll down, and let's go ahead and eliminate one of the variables from 2 of the equations. Now, looking at this, again, everything's nice and neat, laid out for me. I can see that I have plus 18y and minus 18y. So let's go ahead and start with what's easy. Let's take equation 1 and equation 2, and let's eliminate the variable y. So we have negative 3x plus 18y minus 12z equals 19. We have negative 9x minus 18y minus 6z equals negative 19. All right, so if I add the left sides together, and I set this equal to the sum of the right sides, negative 3x minus 9x is negative 12x. 18y minus 18y is 0, so y is eliminated. Negative 12z minus 6z is minus 18z. 19 plus negative 19 is 0. So I'm going to write equation 4 here as negative 12x minus 18z equals 0. All right, so now what I need to do is pick 2 other equations, and again, eliminate the same variable y. So let's go ahead and work with equation 1 and equation 3. So for equation 1, I have negative 3x plus 18y minus 12z equals 19. For equation 3, I have negative 18x minus 6y minus 12z equals 2. Now, if I want these to be opposites, I need to multiply negative 6 by 3. But I've got to multiply both sides of the equation by 3 to make that legal. 3 times negative 18x is negative 54x. minus 3 times 6y is 18y. Minus 3 times 12z is 36z. And this equals 3 times 2, which is 6. All right, let's bring this up now. So let's add the left sides together. Set it equal to the sum of the right sides. Negative 3x minus 54x is negative 57x. 18y minus 18y is 0. Y is eliminated. Negative 12z minus 36z is minus 48z. Then this equals 19 plus 6, which is 25. All right, so let's put this as equation 5 here. So we have negative 57x minus 48z equals 25. So now I have a linear system in 2 variables. So what I can do is, again, solve that. I can use elimination or substitution, really whatever I want. So it looks like I'm going to use elimination here. So I'm going to choose to eliminate the variable z. So how would I do that? If I have negative 12x minus 18z equals 0, and I have negative 57x minus 48z equals 25. What's the least common multiple between 18 and 48? So the LCM of 18 and 48. Well, I know 18 is 6 times 3. So 2 times 3 times 3. What's 48? 48 is 8 times 6. So it's 2 times 2 times 2 times 2 times 3. So my least common multiple would be 4 factors of 2 and 2 factors of 3. So it would be 16 times 9, which is 144. 144. So I want one of these to be negative 144z, the other to be positive 144z. So let's multiply this equation, both sides, by negative 8. And then let's multiply both sides of this equation by positive 3. So I would have negative 8 times negative 12x. That would be 96x. Then negative 8 times negative 18z would be positive 144z. And this equals 0 times negative 8, which is 0. Next, we have 3 times negative 57x. That's negative 171x. Then 3 times negative 48z. That's going to give me negative 144z. And this equals 3 times 25, which is 75. All right, so let's erase this. I don't need any of this anymore. And I'm going to drag this up a little bit. So if I add the 2 left sides together and set it equal to the sum of the right sides, what am I going to get? 96x plus negative 171x is going to give me negative 75x. 144z minus 144z is going to be 0, right? So z is eliminated. 0 plus 75 is 75. So I get negative 75x equals 75. I divide both sides by negative 75. And I get that x is equal to negative 1. X is equal to negative 1. Okay, let's erase all this. Now, if I stay with this system in 2 variables, I'm going to find out what z is. So let's plug into equation 4. We have negative 12 times, for x, I'm going to plug in a negative 1, minus 18 times z equals 0. Negative 12 times negative 1 is 12. So I would get 12 minus 18z equals 0. I would subtract 12 away from each side of the equation. That's gone. I'll have negative 18z is equal to negative 12. Let's divide both sides of the equation by negative 18. So that'll cancel. I'll have z is equal to, we know negative over negative is positive, but we think about 12 and 18. Each is divisible by 6. Divide 12 by 6, you get 2. Divide 18 by 6, you get 3. So z is going to be 2/3. So now let's look at our equations that have 3 variables. I'm going to take one of them, doesn't matter which one, plug in a negative 1 for x, plug in a 2/3 for z. I'm going to find out why. So let's go ahead and work with equation number 1. So you'd have negative 3 times x, again x is negative 1, plus 18y minus 12 times z. Z is 2/3. And this equals 19. Negative 3 times negative 1 is 3, plus 18y. Negative 12 times 2/3. 12 would cancel with 3 and give me 4. So really I have negative 4 times 2, which is negative 8. This equals 19. 3 minus 8 is negative 5. So you'd have negative 5 plus 18y is equal to 19. Add 5 to each side of the equation. That would cancel. You'll have 18y is equal to 19 plus 5 is 24. Now, to get y by itself, let's divide both sides of the equation by 18. This will cancel with this. I'll get y is equal to 24 and 18 are each divisible by 6. 24 divided by 6 is 4. 18 divided by 6 is 3. So y is going to be equal to 4/3. So y is equal to 4/3. So as an ordered triple, again, it's the x value, which is negative 1, the y value, which is 4/3, and the z value, which is 2/3. Okay, so that's going to be your solution to this system. In the interest of time, I'm not going to go through and check it, but I want you to pause the video if you're unsure on how to do it. Plug in a negative 1 for every x, a 4/3 for every y, a 2/3 for every z, and make sure the left and the right side are equal in each of the three equations. All right, let's take a look at another one. So we have negative x minus 6z equals negative 4y plus 4. We have negative 4x equals 5z plus 3. We have 6y plus 2z equals negative x plus 12. So a lot of students see this and they go, well, you're missing a variable in the second equation. That's okay. I'm going to show you how that's going to actually be a benefit to you, and it's going to take less time to do a problem like this. The first thing is I want to write every equation in this format. ax plus by plus cz equals k. So for this top equation, negative x, add 4y to each side, so plus 4y, minus 6z equals 4. For the next equation, negative 4x, I don't have a y, so I can put plus 0y if I want. And then I'm going to subtract 5z away from each side, and this equals 3. For the third equation, I'll add x to each side of the equation, and then plus 6y, plus 2z, and this equals 12. So just as I always do, I'm going to number these. This is equation 1, 2, and 3. All right, now, let's talk about how this is an improvement for us. The one thing is, normally I have to eliminate one of the variables from any two equations. Then I've got to do that again. I've got to eliminate the same variable from another two equations. I notice that this equation does not have a y. It's got 0y. You can basically just take y out. So I'm just going to write this over here as negative 4x minus 5z equals 3. If I just take equation 1 and 3 and I eliminate y, I can write this over here as an equation with x and z only, and I can basically have a linear system with two variables, and I can get my solution very quickly. So I can skip a step when this occurs. So with equation 1 and 3, I have negative x plus 4y minus 6z equals 4, and I have x plus 6y plus 2z equals 12. Now I know some of you will look at that and say, oh, I've got negative x and x. Let's just go ahead and eliminate x. That's not going to do you any good because over here you have x and z. If I eliminate x, I'd have y and z. I need a linear system with the same two variables, okay? So don't think like that. All right, so the first thing I want to do is think about how I can get 4y and 6y into opposites. Well, you think about the least common multiple between the two, and it would be 12. So I want one of them to be 12y, the other to be negative 12y. So I can multiply both sides of this equation by, let's say, negative 3. And I can multiply both sides of this equation by, let's say, positive 2. So negative 3 times negative x would be 3x. Negative 3 times 4y would be minus 12y. Negative 3 times negative 6z would be plus 18z. Negative 3 times 4 would be negative 12. So this equals negative 12. 2 times x would be 2x. 2 times 6y would be plus 12y. 2 times 2z would be 4z. And this equals 2 times 12, which is 24. All right, so let me erase this. I don't need this anymore. And we're ready to add the two left sides together. Set that equal to the sum of the two right sides. So what's that going to give me? 3x plus 2x is 5x. Negative 12y plus 12y is 0, so y is eliminated. 18z plus 4z is 22z. This equals negative 12 plus 24, which is 12. So I've got another equation here. This is equation 2, so I'll keep that number. This will be equation 4. It's 5x plus 22z equals 12. All right. So now we can just solve for x and z and then plug back into one of the original equations. So the easiest thing to do, I think in this case, would be to use elimination. If I have negative 4x minus 5z equals 3, and I have 5x plus 22z equals 12, between negative 4 and 5, the LCM is 20. So I can make one of them positive 20, one of them negative 20, and I'm going to be good to go. So I'm going to multiply both sides of this by 5, and both sides of this by 4. So 5 times negative 4x is negative 20x. 5 times negative 5z is minus 25z. 5 times 3 is 15, so this equals 15. 4 times 5x is 20x. 4 times 22z is plus 88z. And this equals 4 times 12 is 48. Let's erase this. So let's bring this up. All right, so let's sum the two left sides. Set this equal to the sum of the right sides. Negative 20x plus 20x is 0. Negative 25z plus 88z is 63z. And this is equal to 15 plus 48 is 63. So divide both sides of the equation by 63. You get that z is equal to 1. So z here equals 1. So I can plug a 1 back in for z in either equation 2 or 4. Doesn't matter. Let's go ahead and use equation 4. So 5x plus 22 times 1. 22 times 1 is just 22. This equals 12. Let's subtract 22 away from each side of the equation. This is going to cancel. You'll have 5x is equal to 12 minus 22 is going to be negative 10. Let's divide both sides of the equation by 5. We'll get x is equal to negative 2. So x equals negative 2. Now we can take these values, plug them back in for either equation 1 or equation 3, and get a value for y. We can't do that with equation 2 because y isn't there. So in equation 1, I could go minus a negative 2, plug in a negative 2 for x, plus 4y, minus 6z, z is 1, so minus 6 times 1, and this equals 4. So minus a negative 2 is 2, plus 4y, minus 6 times 1, which is 6, and this equals 4. 2 minus 6 is negative 4, so you get 4y minus 4 equals 4. Go ahead and add 4 to each side of the equation. This will cancel. You'll have 4y is equal to 8. Divide both sides of the equation by 4. You're going to get that y is equal to 2. Okay, so y is equal to 2. Let's erase all this. We'll write this as an ordered triple. So it's the x value, which is negative 2, the y value, which is 2, then the z value, which is 1. So negative 2, comma 2, comma 1, or an x value of negative 2, a y value of 2, a z value of 1. That's your solution for this system. All right, so let's look at one final problem. And I know these get super, super tedious. You know, when you start working through stuff like this, you can go through an hour's worth of work and it can be only like 5 or 6 problems. So let's go ahead and start out by just rewriting everything as ax plus by plus cz equals k. For the first equation, I have negative 2x. I'm going to add 4y to each side, so plus 4y. Then plus 4z, and this equals 4. So let's go ahead and call that equation 1. For the next equation, we'd have 4x minus 4y. Let's subtract 6z away from each side. And this equals negative 18. Let's call this equation 2. For the next guy, let's subtract 5x away from each side. Let's have negative 2y next. Then let's add 4z to each side. And this will be equal to -2. Let's call this equation 3. All right, so let's take a look at what we can do here. So I want to start out with any two equations, and I want to eliminate one of the variables. So it looks like it'd be really easy to eliminate y if I worked with equation 1 and 2. So if I have -2x plus 4y plus 4z equals 4, then I have 4x minus 4y minus 6z equals -18. What do we have here? If I add the left sides, set this equal to the sum of the right sides. -2x plus 4x is 2x. 4y minus 4y is 0. That's eliminated. 4z minus 6z is minus 2z. And this equals 4 minus 18, which is -14. So let's say equation 4 here is 2x minus 2z equals -14. Now, I'm going to eliminate the same variable, which is y, from any two other equations. So let's go ahead and use equation 1 and 3. So -2x plus 4y plus 4z equals 4. Equation 3 is -5x minus 2y plus 4z equals -2. So I don't quite have what I need. If this was -4, I'd be good to go. So I can accomplish that by multiplying both sides of the equation by 2. 2 times -5x is -10x. 2 times -2y is -4y. 2 times 4z is plus 8z. And this equals 2 times -2 is -4. All right, so now let's sum the left sides. Set this equal to the sum of the right sides. -2x minus 10x is -12x. 4y minus 4y is 0. Y is eliminated. 4z plus 8z is plus 12z. And then 4 minus 4 is 0. So as equation 5 goes, you would have -12x plus 12z equals 0. So it looks like it would be pretty easy to use substitution here. Let me take equation 4 and solve it for x. So I have 2x minus 2z equals -14. If I want to solve this for x, let me add 2z to both sides of the equation. That's going to cancel. We'll have 2x is equal to 2z minus 14. Let's go ahead and divide both sides of the equation by 2. That'll cancel. We'll have x is equal to 2 over 2 is 1, so it's just z minus 14 over 2 is 7. So we can say that this relates to this. We have x is equal to z minus 7. Now, I'm just going to plug in for x in equation 5. So we would have -12 times, plug in a z minus 7 for x, plus 12z equals 0. -12 times z is -12z. -12 times -7 is positive 84. Then plus 12z equals 0. So I want you to notice something. You have -12z and you have positive 12z. Those are going to cancel. I'm left with 84 equals 0. We've seen this before. Remember, your variable drops out, you've got nonsense, that means no solution. It's the same thing when you're working with a linear system with 3 variables. So there's no solution here. No solution. All right, so we can put the symbol for the null or empty set.